Alright, so now application, so the previous applications were given a graph. In this case, instead of given a graph, we're given a function, but we can still use the graph. But in this case, we'll have to use the graph in our graphing calculator, which I showed you how to do that in earlier videos. Alright, so suppose we're given the marginal profit function. Alright, so our marginal profit, which is the derivative of the profit, is given, alright, where x represents the number of electric ovens, and there's my derivative function, my rate of change, dollars per electric oven. Alright, sketch the graph of the derivative over the domain 0 to 400. And so this is kind of trying to get you to help out with your window. So when you go to graph this, so I'm going to just use, you should just use your calculator. Alright, plug it in. So I'm going to pop my calculator up here. Clear out what I have. So when I plug it into my calculator, negative 0.03x squared plus 9x plus 500. Alright, so I know I'm going to have to change my window, so I'm going to go to window first. At the very least, and I like to leave the negative so that I can see my axes, but at the very least I know I need to go to 400, because that's what they said in my domain, so 400 I might scale by 50 so I don't have a whole bunch of dash marks. Alright, and then the y I also need to change. I might leave it negative 10, but I know I need to go up beyond, and so if I kind of look at my table here, it looks like things are above 500. So I might go 1,000, double my y-intercept, right? My y-intercept is at a 500, right? 0, 500, and scale by 100. Alright, let's see if that gives me, oh, it looks like, again, I can see my graph here, so it looks like it's not quite big enough. So I'll probably go up to 1,500, maybe. See if that gives me a good enough looking. Picture, and there, now I can see the whole function. Except I can't see where it dips off to the negative here, but I know it dips down there below there. Alright, so there's my derivative. So I'll go back and copy that picture in my notes. Alright, so sketch the graph. And so whenever you're asked to sketch the graph, at the very least, again, you should always label your axes with the appropriate units. You should always label your starting point. And so this is the x value, which is the number of electric ovens. This is the derivative, right? So this is the dollars per oven, electric oven. And at time 0, right, when I plug 0 in, it should come out 500. And then, noting my graph before, it's a parabola that goes up and does come down eventually after a certain point. Alright, so there is my derivative of my function from 0 to 400, roughly. And it's a sketch. Sketch means it doesn't have to be perfect, just needs to represent what the picture shows. Alright, so now we're going to shade the region of the graph that represents the definite integral, my derivative of my profit function from 200 to 300, interpret your answers in terms of the applications. Alright, so I'm actually going to do this on the calculator, and then I'm going to go copy it on my picture here. So I'm going to pop my calculator back up. Remember how we do this on the calculator. It's under second trace. It's the very last one, 7. My lower value was 200. My upper value was 300, which is why we needed to make our window big enough. Because if you didn't have your window to cover that, it will give you an error message. Alright, so it shades on that little part of the graph. And the answer is 85,000. Alright, so when I go back to my picture, I shade it in. Again, it should reflect, so 200 was roughly about right here. 300 was roughly about right there. And there's the area that was shaded in. And so again, this area came out 85,000, which is what this integral equals. So remember what that integration means. That integration really is the difference between the profit at 300 versus the profit at 200, right? That's the net change theorem. That's what that integral equals. Well, that difference was 85,000, which tells me if they increase production, increase sales, from 200 to 300, and specifically that 100. If I went from 100 to 200, I might get a different answer. If I went from 150 to 250, I would get a different answer. So we increase specifically by that 100 units in sales. So if sales of electric ovens increased from 200 to 300, then profits will have a net gain, net increase, however you want to word it. Should be a positive though. A net increase. Remember, it's the additional profit. All right, profit doesn't equal 85,000 at that moment. It's the additional profit from those 100 units between 200 and 300. All right, so the profit will have a net increase of 85,000. That's how much more they gain, right? From those 100 units sold, they gain $85,000 more in profit. All right, and then they have to decide if that's worthwhile to them or not. That's not how much profit they get. That's the gain in profit, the additional profit from selling those extra 100. Alright, we'll stop there. We'll pick up the next. I'm going to do these just one at a time, because I just think it's easier that way. So I'm going to stop there and pick up the next example in the next video.